we are asked to evaluate the indefinite integral as shown. We first observe that the integrand consists of a rational function with an unfactored denominator, and the degree of the numerator being smaller than that of the denominator. Let's first check if the denominator factors. So 2x squared plus 5x minus 3, if it factors, needs to look like this. 2x plus minus something times x plus minus something else. Now, because negative 3 is our constant term, we must have 1 times 3 sitting in these brackets. And because we have the middle term 5x, we see that our 3 needs to be here and the 1 here. And because of the positive and negative signs, the way they are placed, this here must be positive and our very first term must be negative. So indeed, our denominator factors. We make use of this and now rewrite the integrand as a partial fraction to solve our integral. So 9x minus 1 all over the denominator 2x squared plus 5x minus 3 is equal to some numerator divided by 2x minus 1 plus some other numerator divided by x plus 3. So this means we need to solve the equation 9x minus 1 is equal to a times x plus 3 plus b times 2x minus 1. There are a variety of ways to proceed from here. For example, guess and check, or setting up and solving a system of linear equations. We will solve by making each linear factor 0 in our equation. We choose x is equal to negative 3. Then our equation becomes 9 times negative 3 minus 1 is equal to, well, the very first term becomes 0 now, b times 2 times negative 3 minus 1. As we simplify, we get that negative 28 on the left side of the equation is equal to negative 7b on the right side. And so this means that b must be equal to 4. Analyzing our equation with b equals 4, we see that a must in fact be equal to 1, because 4 times 2x is already 8x, and so a can only be 1. So let's record a is equal to 1. We are finally in a position to integrate our integral. Let's call it I. Then I is equal to the integral of the very first partial fraction, namely 1 over 2x minus 1, plus the second partial fraction, namely 4 over x plus 3 dx. And we can see that this is readily integrable, and so our result will be the natural logarithm of the absolute value of 2x minus 1 as the antiderivative of the first term, but by the chain rule we also need to now multiply this by a half, plus similarly the natural logarithm of the absolute value of x plus 3. And since the derivative of x is simply 1, we are done. And also because we have an indefinite integral, we cannot forget to add a c. You can now differentiate this result to check that it will yield the given integrand.